In Euclidean geometry, we have learned about the characteristics of different quadrilaterals. If you are not yet familiar with these, please go and watch our videos in the Euclidean geometry section. In this video, we are now going to use these characteristics to help us work with quadrilaterals on the Cartesian plane. Let's look at an example. In the diagram, QUAD is a rectangle. The coordinates of A are -1, 7, and the coordinates of U are -7, 5. P, with coordinates T0, is the point of intersection of AQ and DU. Determine A, the gradient of QU, B, the length of QD, C, the value of T, and D, the length of AQ. Let's start with part A. Determine the gradient of QU. Now we have the coordinates of U, but we don't have the coordinates of Q, so we cannot find the gradient this way. But the question tells us that quad is a rectangle. We know that each interior angle of a rectangle is 90 degrees. So let's draw in our right angles up here and down here as well. Because each angle is 90 degrees, we know that the adjacent sides are perpendicular. This means that QU is perpendicular to side AU. We have the coordinates of point A and of point U. So let's find the gradient of AU, and we can use the gradient formula. Let's say that U is our first point and A is our second. So we can say the gradient M of AU is equal to the y coordinates 7 minus 5 divided by the x coordinates -1 minus -7 becomes +7. 7 minus 5 gives us 2 over -1 plus 7 is +6. Now we can simplify our fraction. 2 and 6 are both divisible by 2. And we get a fraction of 1 over 3. QU is perpendicular to AU. So the gradient for QU will be the negative reciprocal value. So we can say the gradient of QU is equal to the gradient of AU is positive. So this becomes negative. Let's flip our fraction and we get 3 over 1, which is simply 3. And now we can move on to part B. Determine the length of QD. We don't have the coordinates of point Q or point D, so we can't use the distance formula to find the length. But quad is a rectangle, which means that opposite sides are equal. QD is opposite to AU, which means that both of these sides are equal in length. On our diagram, we can draw a small line on UA and a small line on UD. These small lines show us the lengths of these two sides are the same. We have the coordinates of U and A, so let's use the distance formula to find the length of the side.